To model cooling units in a raised floor data center, you can do it in one of two different ways. You can either use the library system and select equipment that is already pre-manufactured or set up by the pre-manufacturer specifications, or you can create your own. I'm going to show you how to do both in this video. So first, let me show you how to make one of your own. So here in the upper left-hand corner, you see all my objects, and I'm simply going to use my left mouse down, and I'm going to drag and drop a cooling unit into the room. Now you notice that's a default cooling unit. You notice it has a CRAC extension already on it. So it is a smart object. It knows that it's a raised floor data center with a ceiling plenum return. You can see the mark for the ceiling right here. And the air is going to be coming out of this top, or I'm sorry, going back down into the top there. So that's the return. And then if I turn this over, roll this over using my left mouse, I can see the arrow indicating the air that will come out of the bottom. Also, this light line, it's kind of a magenta line here, represents the outlet. That's the size of the outlet. The air will come out of that entire cross-section, and therefore the velocity will be proportionate to the flow rate divided by the cross-sectional area. Same thing on the top. The yellow indicates the return. So it's really just a box or a block with an inlet and an outlet on it, and air is going to come in here and go out the bottom. Now when you double click that and open up the editor, let's take a look at what's in there. This particular unit is defaulted as a downflow. We can change it if we like. We can change it to a front flow, which is often referred to as an in-row. Or we can change it to an upflow, where the air goes in the front and out the top. So we'll leave it as a downflow for now. We can put in manufacturer if we like. These are all editable, so if I wanted to change the manufacturer, I could. If I wanted to put in a model number, I could. Color is something I can change. Notice cooling capacity is grayed out for now. We'll go over that in a moment. So now in geometry, the size of this particular unit is 2.917 by 4.167. Don't know exactly why. Probably because it came originally from something that was in metric. Yes, it did. You can tell the metric numbers are pretty clean. And it is just a default size. We can change this to whatever we want at any time we want. And we can also make a copy of it and put it in our own local library. So let's start by changing some of the thermal characteristics. Now here we have a couple different things. One is the flow rate. Now for any cooling unit that you find anywhere, there's always going to be a flow rate associated with it if you look it up on the internet. So if the unit that you're looking for is not in our local library, then what you do is take the default unit and, most importantly, put in this number, whatever this number happens to be. We'll put in 10,000 for now as a flow rate. Now you also will want to change the cooling capacity, only because it comes up in the output report. We'll review that later. So let's change the cooling capacity to something higher. So let's put this in as maybe 10,000 CFM, so maybe it's 100 kW. Whoops, 100 kW. I don't know exactly, but my point is you can edit this to whatever you want. Now, there are four boundary conditions here for this cooling unit. There's cooling capacity, temperature drop, performance data, and supply temperature. Let me review them with you. Supply temperature is the easiest one to use. It is the default for the unit. And this allows you to just set a cooling supply air temp and go ahead and run the model. And it will always have that supply air temp. Now there's a bit of a danger there because it assumes the device is perfect and can deliver an infinite amount of cooling capacity. That's the only danger with this particular parameter. But it's a great one because usually you have enough cooling capacity in the room. It's usually not an issue of cooling capacity. Furthermore, if you do exceed the cooling capacity of 100 kilowatts, it will show up in the output report, and it'll show up in red. So it's a definite indicator there's a problem. But it's a good one, and the way that I do it often is go into the data center, if there's one, if it exists, take a measurement of the cold air coming out of the supply by lifting a tile and just using a infrared gun or something else to shoot the temperature, get a sample of the temperature, and I set this parameter. So this is set by measured data if you have it. If not, it's certainly a great way to see how high you can raise the supply air temp before you get into trouble, so it's a great parameter for doing design optimization. The others, let me go through them. Cooling capacity takes the cooling capacity number and starts to cool the data center based on a thermostat. The thermostat can either be on the return or supply. Now if you put the thermostat on the supply side, it's really not much different than the constant supply air boundary condition I just showed you. If you put it on the return, which by the way is default and by the way is normal because cooling units usually have the sensor for the thermostat on the return, then what it is going to do is it's going to sense the average return temperature coming into this return, and it's going to either increase or decrease the cold air supply until the average, the difference between the average return temperature as seen on that return on the cooling unit, the difference between it and this thermostat temperature is 0. So in this case, it would throw cold air until the thermostat reached 75 degrees, and then it would begin to decline until it reaches a steady state situation. And that may take some time because it does iterate. So this one takes a little longer in terms of solve time. And it also assumes a linear relationship between return air temp and cooling capacity, which is not exactly true. It's actually a nonlinear relationship. As return air temperature rises, the cooling capacity goes up. It is not constant. And that's what this one is for. Performance data allows you to build a table. And the table has a number of entries. You can have up to 10. And it will allow you to build a table to record the relationship between return air temperature and cooling capacity. Now, this data is not always easy to get. The data that we do have is already in the library units that come with CoolSim. And it's pretty available for Liebert, or now Emerson, cooling units. Not so available for everybody else. So in the essence of expediency, what I tend to do is use the supply air temp cooling capacity, supply air temp boundary condition to drive the model. Okay, now also down here we have on-off states. You can turn the CRAC off. You can make the CRAC a fan, and that means it rejects no heat. Or on. So you have on-off. When you turn the unit off, you will notice the arrows go away. So visually, if you want to know a CRAC is on or off, look to see if the arrows are in place. If there's arrows there, that means it's turned on. If there are no arrows there, that means it's off. So we use that arrow decoration as a way to indicate they're on or off. The only other thing here that I'll point out is that there is also the opportunity here to use a fan curve. The flow rate mechanism or the specification can either be constant or fan curve. A fan curve allows you as well to put a table in, a table of decreasing flow rate with increasing static pressure. And the default there is for the same 3200 CFM that this default unit is for. This is rare that you need this. It's unusual that you get into a case where you need a fan curve, but if you do, we support the ability to put a fan curve in. fan curves are effectively the idea of a fan not being able to handle the delta in pressure required to drive the air under the floor in this case. And that sometimes happens. It particularly happens with EC fans more than anything else, but it is something to be aware of. So if you have a case where you need a fan curve, you can switch this on. You will need to edit this table to determine how many points you have and what the characteristics of the fan curve are. You will need to get that from the manufacturer or a fan manufacturer. Or if you need help, contact us and we'll help you with it. support@coolsimsoftware.com. We can help you with fan curves should you need them. It's unusual that you will. Now before we leave, let me point out that I changed some of the thermal data. We can also change the geometry data. We can make the unit bigger or smaller. We can modify the supplies and returns. We can change the quantity of them, and we can change the size of them. And one thing that I see a lot is people use this particular method to create their own unit, and then they'll make these. They'll make it larger. Let's say that it's 4 feet in one direction and it's 6 feet in another, and it just happens to be the machine that they're working with or the cooling unit they're working with. Now when you do that, you'll notice that the supply and returns did not scale with the model. You see how it's smaller? It's the same size. The outlet is the same size as the original unit. So to correct that, you need to scroll down here and go to Modify Supply, and a dialog will come up. They're popping up on my other screen. And if you want to make it the same size as the geometry of the cooling unit, which is typical, then you'll want to hit the Auto Distribute button, which changes those dimensions, and then you apply it. And it will update and give you the correct size. Now when you're done, by the way, you'll want to do that to the return as well, because its size needs to be corrected as well. Now when you're done with this unit, there's a couple of things you can do with it. You can certainly label it like we did with our information, and we can say, okay, now I've built this unit. Now it is going to be my unit. So in general, I'm going to name it Paul's AHU, and the model number is something 1, 2, 3, 4. Now, once this unit is done, we can certainly Control-C, Control-V it and replicate it, but we can also add it to our own library. So under Library Options, which is a right mouse, we do a lot of right mouse work in CoolSim. Right mouse click allows you to put this in your own user library under that name. So I can add it to my user library, and then I can use it again later. So let me just show you the library system. View library is how you get at it. It's up here in the center of the screen. And a library system will pop up, and it will take a second to populate. And then we can choose, for example, a cooling unit from, in this case we want a downflow, and let's take one from Stoll's, and we're going to want a pretty big one, so let's sort by cooling capacity, but we'll flip the sort upside down. We'll grab one of their big units and drag it in. It's a drag and drop. Hold your left mouse down to drag it in and let go, and it will show up. If it doesn't show up, then just shut the library system. The library system should sit over here on the left, and when you mouse over it, it will pop out. Otherwise, it disappears. Now, I can also do the same thing with the user library that I just created. So we can go to User Library, and we can take a look under cooling units. Those would be CRACs. And you see here, there's Paul's AHU right there. I just put it in. Same thing. I just drag it and let it go. So I can create my own units and save them and adjust them appropriately. If I want, for example, to put a ceiling plenum on this, I can just go here and scroll down and put plenum extension. It will connect that up to the ceiling, and everything will work just as expected. If you find that you need a cooling unit that's not in the library, you can send us a note. We will create one for you and send it to you. All of these units can be exported as well. There's an export button right here which allows you to write them out to a file system as a simple CSO object, and they're quite small, and we can send them to you and you can just read them in to your system using the import object feature. So if you need any cooling units, let us know. We'll help you. That's a quick overview of how cooling units work. Thank you.